Testing audio. Right. Okay, let's start. What about the audio and video? Oh, it's fine, right? Right. Okay, let's start. About the audio and video. Okay, it's working fine now. Right. All right, then we'll start. Good evening. Everything is working fine, right? 1 second. Okay, right. All right, so we are in day 18 of S2A, and we are like 5 weeks from the exam, right? Day 18 of S2A and 5 weeks from the exam. Right now, it's like 37, 38 days remaining to the exam. Now we have come down to the last month, right? We have come down to the last month before the exam, right? The last month, very last month before the exam, right? So time flies, right? And things are happening around now. Today I was a little bit late because when we finished the theory class also today it was a little bit late today, right? Then when I prepare myself, refresh and prepare myself, it took some time, right? So that's why I had to like wait it for like 15, 20 minutes, 15 again, 15 minutes to start, right? Right, so today my plan is to discuss some mechanics questions from the past papers, and yeah, things are happening. Stay updated. This Sunday we'll be having the capacitor seminar, right? This Sunday we'll be having the capacitor seminar. There I'll be finishing everything. We'll be discussing and finishing everything about capacitors, right? We'll be discussing and finishing everything about capacitors from scratch, everything, right? From scratch, everything you need to know about capacitors, because when it comes to capacitors, and when it comes to capacitors, that is also a definite MCQ you are going to get, right? That's a definite MCQ you are going to get. That's a definite one. Right? Other than that, capacitors are sometimes involved with essay questions also, right? Capacitors are sometimes involved with essay questions also, right? We can't like promisingly say all essays are coming in capacitors. That's not the case, but always MCQ is coming only. I mean, at least one MCQ, not only one, but at least one MCQ is coming from capacitors, right? 1 second. And uh, right, at least one MCQ is coming, and uh, about essays we can't say anything like promisingly. That's the thing, right? Can come or sometimes cannot come, because sometimes there is linked to questions like electric fields, right? And sometimes electricity and capacitor questions are coming, and capacitor questions are coming, but okay, but sometimes it's not. So we can't promisingly say what to expect about capacitors in terms of essays, but the MCQ is definitely there, right? So therefore, we'll be having the capacitor seminar this Sunday, right, at 7 p.m. And the last practical seminar I'm going to have, that will be also happening soon, and the planned date for now is 19th. Planned date for now is 19th. Sometimes there's a probability of taking it to 12th as well, that I'll confirm, right? Otherwise, the planned date is 19th. Sometimes it can be on 12th as well, right? So those are the things coming up, right? Now, since the academic things, I mean syllabus things are over, right? Now in the classes also we are mainly giving our focus to question discussions, right? Question discussions, lesson based discussions, question based revisions, right? Or lesson based revisions likewise, right? So that's basically the plan. Okay, then now today is day 18, right? I send the questions, I think, in the afternoon. Sometimes you might have downloaded and tried, right? Now without any further ado, let's go to the discussion, right? Without any further ado, let's go to the discussion and see, right? Screen is visible, right? Okay, right. Let's see. Question 1. You are asked to determine the density of a material. Now, one thing, a small analysis about question 1, right? So, I have already shared this analysis also, right? If you don't have an idea what has come in last 11 years or last 11 to 15 years, right? You can check that on the YouTube channel, right? I have shared something called question analysis for structured essays, right? So there I have analyzed all the questions starting from 2015, right? 2015, 15 I can, as I can remember, right? Then yeah, last 11 years I analyzed. Then you can see what has been already come and what to come. I mean, what's possible to come this time. So likewise, have an understanding, right? That's the main purpose behind doing those analysis and everything, sharing with you all know, right? So get that advantage. And when it comes to question 1, right? We know when it comes to question 1, structure is A1, right? There are a few more things that can be here. One thing is measuring instruments. Measuring instruments can be here. Measuring instruments. One thing is measuring instruments, right? And second, mechanics ones. Mechanics ones, right? Mechanics experiments. Any out of these 5. And then simple pendulum or helical spring, right? From oscillations, right? Oscillations are also coming here as question 1. And other than that, the other experiments like properties of matter, right? From properties of matter, Young's modulus, determination of Young's modulus, or it can be a surface tension experiments, Jaeger's method, right? Likewise, Jaeger's has not yet come, right? Jaeger's, or there are 2 other experiments using chemical balance or a glass slide. Sorry. 2 other experiments using chemical balance or glass slide, right? So if they come also, they also come under here, right? If you add up all the questions, right? There are around here measuring instruments 4, mechanics 5, here 2, and here it's around 4 again, around 15 possibilities to come as question 1. Around 15, 14, 15 possibilities to come as question 1, right? So have that understanding when you are sitting to the exam. Sorry, I didn't share the live to the groups. Give me 1 minute. I'll share this in the groups and come, right? 1 second. I forgot to share this in the group, in the channels and groups. 1 second. Hold on for a moment. Haven't I shared the screen yet? What has happened to the screen share? I shared no. Is it gone? So I thought the screen is shared and I was writing something on the screen. Okay, now you can see, right? Right, 1 second. Isn't my screen visible yet? What's happening? One second. What is it wrong with my link today? Oh, okay, now fine. Sorry, 1 second. Okay, now I think it's shared. Okay. Right. That's enough. And the other thing, why don't you see my screen? What about now? Now visible. What about now? Okay, now it's fine, right? Okay, now it's fine. No? So what I was explaining, listen, what I was explaining was when it comes to question one, right? When it comes to question one, there are few more possibilities that it can be here as question one, right? There are few possibilities that can be here, right? One is measuring instruments. From measuring instruments, we have 4 experiments, right? Then mechanics. From mechanics, we have 5 experiments, right? Then from oscillations and not waves, from oscillations, 2 experiments. They are namely helical spring and simple pendulum. And properties of matter, there are 3 experiments from surface tension and 1 from Young's modulus. It's 4. So basically, it sums up to like 15. Then the number of questions that can be coming as question one is a little bit higher compared to other questions, right? Number of possibilities can be as question one is a little bit higher, right? So just know these things before sitting to the exam, right? Before going to the exam. Right. Now let's see. Let's go to the discussion, right? Right. See, first one. You are asked to determine the density of a material of a thin uniform wire of length about 15 centimeters, right? That is important, about 15 centimeters, because when we are asked to find the device to be used to find lengths, those things, right? 15 centimeters is needed, right? 15 centimeters and mass about 200 milligrams. So 200 milligrams. You are provided with the micrometer screw gauge shown in figure 1 to measure the diameter of the wire, right? Name the parts of the micrometer screw gauge, right? Very straightforward. Name the parts of the micrometer screw gauge marked as AB. Marked as AB, not the 2 scales, right? Okay, not the 2 scales, right? And C. Then what is a sleeve, right? A is not the scale, right? That's a sleeve. A is sleeve, right? Then B thimble, straightforward, thimble, and C thimble head. B thimble head is also called the ratchet sometimes, right? Ratchet के लिए वो तौलन है, thimble head or ratchet. Right. B. The main scale of micrometer screw gauge is made by dividing 1 millimeter into 2. The circular scale has 50 equal divisions. One complete turn of B will either increase or decrease the distance between the anvil and spindle by a value which is equal to 1 division of the main scale. Right? Now this is made by main scale is main scale is made by dividing 1 millimeter into 2. Right? What is the pitch of the micrometer screw gauge? Then there is 1 millimeter over 2, no? Pitch is 1 millimeter over 2, then 0.5. It is 1 millimeter over 2, that is 0.5 millimeters. 0.5 millimeters. Right, next one. What is the least count of the micrometer screw gauge in millimeters? We know least count is given by, right, pitch over number of divisions in circular scale. Pitch over number of divisions in circular scale. Then this is given by pitch over. No need to write the equations. I'm writing the equations for your reference. Right, otherwise no need to write the equations when you are answering this. Right, pitch over number of divisions in circular scale. Pitch here is 0.5 millimeters. Number of divisions in circular scale 50. Then that is 0.01 millimeters. Right? 0.01 millimeters. Next one. Figure 2 shows the position of circular scale when the anvil and spindle touch each other. So we know zero error is checked by touching anvil and spindle each other. Right now, this is going to check the zero error. Touch each other. Determine the value of the zero error of the micrometer screw gauge in millimeters. Right. If zero is above center line, that is a negative error. Right. If zero is above center line, that is a negative error. Right. That's a negative error. Then this negative zero error is always total minus coincided, no? Coincided divisions is 45, 46, 47, 48. Right? Then total minus coincided 50 minus coincided into least count 0.01 millimeters. That is 0.02 millimeters. 0.02 millimeters. Right? Then after determining the zero error, state how the micrometer screw gauge is used to measure the diameter of the wire. Right? Now zero error is known. Zero error is known. Right? Then to measure anything using micrometer screw gauge, we have to keep it in between anvil and spindle, and we are rotating. Right? You are rotating the thimble head. Right? You are rotating the thimble head until a ticking sound is heard. Ticking sound is heard means that is firmly tight in between anvil and spindle. Right? Without over pressing or over pressurizing. Right? Without being over pressing, over pressurized, that is firmly tight. Right? That is firmly tight. If once again, that is firmly tight if ticking sound is heard. Right? And then since we are taking a diameter of a wire, have to take minimum of two readings in two perpendicular directions. Right? Then two parts are no, then have to mention both accordingly. Right? Then write down the first one. Write down the first one. Keep the wire in between anvil and spindle. Keep the wire in between anvil and spindle and rotate thimble head until a ticking sound is heard. Right? Then the other thing is we can't we can't get satisfied just by one reading, because that's a wire, right? Higher the number of readings we can take, right? Higher the number of readings you can have, higher the accuracy, right? Minimum two, right? Then take minimum two, or you can say several readings. Take minimum two, or several readings in perpendicular directions. And take the average. Right? So those things must be there. E. What is the purpose of having part C in micrometer screw gauge? What is part C? Part C, thimble head. I just mentioned the purpose, right? To avoid overpressing or over pressurizing the wire or the object. Object no problem, because any object that you are keeping in between anvil and spindle, right, cannot be overpressured, because if there is overpressured, what happens is its cross-sectional area is going to damage. When cross-sectional area is damaged, you are not going to get the exact correct reading, right? So that's the idea. Then write down to avoid overpressing of the object or wire kept in between anvil and spindle. Anvil and spindle. Right? F. Figure 3 shows the position of the circular scale when the diameter of one place of the wire is measured using the micrometer screw gauge. Mentioned in Z above. What is the reading of the micrometer screw gauge in millimeters? Right? Just take this reading. Only 0.5 is completed. Only 0.5 is completed. Then from main scale, reading is 0.5 millimeters. From vernier scale, right? 5, 6, 7, 8. Then 8 coincided divisions, 8 into, please count 0.01. Right? Then 0.58, no? 0.58 millimeters. What is the correct value of the diameter of the wire in millimeters? Correct value. Right? We know we had a negative error of 0.02, no? Then correct value is 0.58 plus that 0.02, that is 0.60 millimeters. 0.6 is not a word mark, 0.60 is a must. 0.6, just 0.6 is not a word mark. 0.60. Calculate the cross-sectional area in square millimeters of the wire using the value in F1, 1 and 2, F1, 2. Ne? All right, this one. About take 5 equals 3. Then A equals, we know area is 5r squared, no? Right? 5 is 3. And this is diameter 0.6. Then radius is 0.3. 0.3 squared. Right? Simplify. 3 times. Right? 0.3 means 3 times 10 to the minus 1. Then 9 times 10 to the minus 2. 27, which means 0.27 square millimeters. 0.27 square millimeters. Right? A small simplification. G. What other measurements do you take to determine the density of the material of the wire? Density. Right? To find density now, what we only know is the area. Then we have to have the volume. To have volume, we need length. Then length of wire. Length of wire. Right? And second one, obviously we need mass, because density is mass or volume. Then mass of wire. Mass of wire. Right? Second one, name the most appropriate measuring instruments needed to obtain the measurements mentioned in G1 above. Right? Then to find the length, it says initially it was given as 15 centimeters, no? 15 centimeters. Then to get a reading like 15, what we have is meter ruler. Meter ruler. Then in this correct order, you have to mention, because numbers are given as 1 and 2, meter ruler. Right? Then to measure mass, mass of wire, mass for mass also, a hint was given as 200 milligrams, right? 200 milligrams. 200 milligrams. Then to measure mass like 200 milligrams, right? So either you have to go with electronic balance or 4-beam balance. Electronic or 4-beam balance. Chemical is also fine, but no need to go into something like chemical. Electronic or 4-beam balance is fine. Electronic or 4-beam balance is fine, right? Otherwise, triple beam balance is not suitable because its least count is 0.1 grams, which means 100 milligrams, right? 100 milligrams, least count is 100. Then the reading you are going to take is around 200. Then percentage error is very high. Percentage error is very high. Then triple beam is not suitable. It should be either 4-beam or electronic, right? Either 4-beam or electronic balance. Either 4-beam or electronic balance. Right? H. Figure 4 shows an electronic micrometer screw gauge used in industrial applications. What is the least count of this gauge in millimeters? Here a reading is given, no, see, 6.467 millimeters. Then readings are given up to 3 decimals. Then least count must be 0.001 millimeters. Least count is 0.001 millimeters, right? Right. So that's it for question 1, right? Ask if anything, right? Ask and get it clarified if anything. Ask and get it clarified if anything about question 1 we just finished? Right, anything? Is it clear? Okay, right. Right, if clear, let's go to the next one. Right, if clear enough, let's go to the next. Right. Question 2. See, that's from a helical spring. So as I told you, right, there are quite a few questions which are possible to come as question 1, right? Which are possible to come as question 1. We have to know those possibilities. You have to know these possibilities when you go to the exam. Right. Question 2. A mass M is suspended by a helical spring with a pointer attached at the lower end as shown in figure. Right. This is the pointer. Pointer is given. Right. The student is asked to verify the relationship between the mass with periodic time t of a vertical oscillations and determine the spring constant k by using graphical method. Right. This is our standard experiment. No? This is our standard one. This is our standard one. Right. So we have no idea about this standard one. A1. Write down an expression for periodic time t of vertical oscillations of a mass m suspended by a massless spring of a spring constant k. That's a crude equation. T equals 2 pi root m over k. 2 pi root m over k. Right. Next, rearrange the expression written in A1 above in order to verify the relationship between mass and periodic time by plotting a suitable straight line graph, right? So we know to plot a straight line graph, we have to square this and remove this square root, right? Then when this is squared, then t squared equals, this becomes 4 pi squared, right? And k is a constant. We are going to change mass, no? Right? Then you better isolate mass to plot a straight line graph. And if you identify the variables, this is how it should be, right? Identification of variables is not expected, right? Only for your reference, right? If you identify variables, right, this is x, m is x, gradient, and t squared, whole t squared is y equals mx. Straight line graph, y equals mx, right? Part B, if the student is provided with a set of 50-gram weights, what is the other essential measuring instrument that needs to do the experiment? Weights are there, then you are going to find times, right? By changing weight, right? By changing weight, we are going to find the time of an oscillation, right? Periodic time. Then we need a stopwatch, right? Straightforward. Stopwatch, right? 2. It is advisable to use a locating pointer. In the experiment, right? Use a locating point in the experiment. Draw an arrowhead at the appropriate position of the pointer in the above figure, right? Now, this is the right, this is the equilibrium position of the spring, no? Then pointer should also be connected to the equilibrium position, right? Because our focus is identifying the starting and end points of the oscillation properly. Then it should be connected to here as it is very much closer to this one, like this, right? Not in contact, but it should be close enough, right? Not in contact, but should be close enough, like this, right? Not in contact, but should be close enough, right? That is only acceptable answer, and it should be horizontal. Otherwise, if you have drawn something inclined, no marks will be offered, right? If that is inclined, right, should be exactly in front of that given pointer horizontally, like this, should be very close. Then only we can observe this motion, these oscillations clearly, accurately, right? Okay, then what is the purpose of using this locating pointer? That's the whole purpose, right? Whole purpose is we have to determine the starting positions, starting and end points of the oscillation accurately, right? Have to determine, have to find the starting point and end point of an oscillation accurately, because otherwise, how to calculate the time, periodic time? Periodic time is always measured from beginning to the end, no? Right? Then purpose is determining starting point and end point. Starting point and end point of oscillations, right? Of oscillations accurately. Of oscillations accurately, right? Then see, why does the accuracy in determination of spring constant K depends mainly on the accuracy of determination of periodic time, oscillation period time of oscillation of mass. What's the reason? Now we are going to find K, but K depends on T squared. K depends on T squared. Even if you made a small error, that small error is squared, right? It is squared when it comes to the equation. Then, right, even though the error is, say, your error is 2, then it becomes 4 when it comes to the calculation. If your error is 4, then it becomes 16 when it comes to calculation. So likewise, it's squared. Then the impact is high, right? The impact is high. Then you have to mention that point, even though that's a small error, right? Small error, it results in a T squared when using in the equation, right? Then write this way: since T squared is used, in the equation, or you can say in the graph also, in the graph, the error made becomes higher, Second one, what is the characteristic property of the instrument mentioned in B1 above, which affect the fractional error of the time measurement? Affect the fractional error, no? Fractional error is least count over reading. Then obviously there is a least count, right? Let it be X. Okay. Then it should be least count. Right? Fractional error effect very straightforward. A straight answer. Right? Second one. Third one. Let the approximate time per oscillation be T. Write down an expression for the minimum number of oscillations N that should be taken in terms of X and T in order to obtain a percentage error of 1% period time determination, right? So in the practical seminar also we got this idea. Now percentage error is 1%. Then percentage error is 1%. Then 1 equals, right? Least count over reading. Least count is X. It's given here, right? Let the value assume as X. Least count is X. The reading, say n number of oscillations are counted. Then time takes for one oscillation is T, right? The approximate time per oscillation is T. It's given, no? Then total reading is NT. Into 100%. Right? Now we asked about N, right? N, yeah. Then subject N from this. Then N equals 100x over T, right? 100x over T. 100x over T. D. The student obtained the following graph in order to calculate the spring constant K of the helical spring. Graph is given. Right. Calculate the spring constant K of the helical spring in SI units using the above graph, take 5 squared 10. Okay, 5 squared is given, it's asked to take as 10. We have to select 2 points for the gradient now, because now what is my equation? T squared equals, T squared equals 4 5 squared. See, my equation is, see, T squared equals 4 5 squared over K times M. Then we need gradient for this. We need gradient for this, right? We need gradient. This is in the gradient, inside the gradient. Now my target is finding gradient. To find gradient, select 2 accurate points. Accurate points means always your points you select, right? You are selecting should go through an exact intersection of the grid, right? Should go through an exact intersection of the grid, right? See, from here, see, this goes through an exact intersection. No, මේ වගේ points වල mark කරගන්න. See, this is one of the points, right? What's the reading there? Coordinate 80 30, no, right? 80 30. Then this is 80 30. 80 30. And likewise, select another one which exactly goes through this, right? This one. What about this? That is 201 2 200. Sorry, sorry. The best point is this one here. This is the best, right? That is from this side 280. From here that is 80. 280 80. 280 80. So likewise, selecting 2 best points is up to us, right? Always, right? Always it should be the best points which intersects the grid properly. Right, now find the gradient. Then gradient of graph, say m dash equals delta y over delta x, no? Right, delta y is 80 minus 30. 80 minus 30, that is in 10 to the power minus 2, right? Very important. Otherwise, if you miss that 10 to the power, again, you are never going to get the correct answer. 80 minus 30, 10 to the power minus 2, over, right? Over. Then x difference, 280 minus 80. 280 minus 80, right? That is in grams. Then have to convert to kilograms. 10 to the power minus 3. Right? Simplify. Then 80 minus 30, 50. 280 minus 80, 200. Right? And here only 10 remains. Then 500 over 200. 500 over 200, right? Right. Maybe the gradient. This is only the gradient. Now, we know gradient is, now not just the gradient is asked, K is asked. Right? This is the gradient. Right, let me keep the gradient like this. 1 2 1 2 cancels. Gradient is 5 over 2. Gradient is 5 over 2. Right, now, right, if you are doing the calculation at once, totally fine. Right, now gradient is 4 5 squared over K, no? Then 5 over 2 equals 4 5 squared is asked to take as 10 over K. Right, then 5 times 2 here. Then K equals 4 times 4, 16. Spring constant is in newtons per meter. Nm minus 1, that is 16. Right? So likewise, a small calculation using the gradient. Right? Small calculation using the gradient. Right? Second one, give the reason for obtaining a non-zero intercept. That's a common question, a common and popular question asked in most of the cases, mentioning that there are errors in data points is not an acceptable answer. Right. The only reason to get an intercept if there are no errors in the readings in the data points is, now even though we assume this spring as massless, right? It is not massless, no? Then that mass also, that is also in the calculation. That mass is also in the calculation. That's the thing, right? So even though we assume, right, we have assumed already. That's true. Even though we have assumed, in reality, right, it has a non-zero mass, right? It has a non-zero mass. So that has come into the calculation, right? That's why the intercept comes, right? Intercept right? The reason is mass of spring is mass of spring is not negligible, or you can say considerable. Mass of spring is not negligible, right? Or that is considerable, right? So simply what happens here is this, right? Mass එකක් තිබ්බනම් මොකද වෙන්නේ? Right? We know P is given by 25 root m over k. Now here mass of the spring also comes like this. Mass of the spring also comes like this. Then when you write the equation, then it is like T squared equals 4 5 squared over k, right? 4 5 squared over k, simple m plus capital M. See? Now from this, the intercept comes 4 5 squared over k times simple m plus 4 5 squared over k times capital M, right? This is mx plus c. This is mx plus c. That's why the intercept comes. Right? It's kind of a popular and a common question. Keep them in mind, right? So I think in the practical seminar also I clearly stated that point. Right? I clearly stated that point. And I was publishing all the practicals one by one for 2 weeks now, and I'll be keep publishing in the coming weeks also, and I'll be publishing all the practicals, right? All 34 we have now. After all removals, I'll be publishing for your reference, right? So feel free to watch these practicals if needed. That's the purpose. Otherwise, everything was there in the practical seminars, right? Now I trimmed all the practicals, and now I published practical wise for the ease of reference when you check, because if you need to check only for one practical, check only one practical, right? You can just search and get it, no? Otherwise, it was chaptered in the seminar also. Okay, that's it for question 2 also. Any questions? Any questions? Anything? Is it also clear enough? Right. Right, we can move on if clear. 3. Right, now when you are sitting on these S2A discussions, right, do this in a very relaxed manner, because now you might also be fed up after the classes throughout the whole day, right? And I'm also after 3 classes today and doing this now, right? So just do it in a relaxed manner. That's it. Yeah, overstressed whenever. No need to get overstressed, but especially when you are in the S2A discussion, right? This is something that you can do in a relaxed manner and check your knowledge. That's it, right? Something to check your knowledge. Right, part 3. Sorry, question 3. Question 3. You are asked to find the mass of a piece of rock of irregular shape having a mass of the order of 60 grams by performing the experiment which uses the principle of movements. You are provided with only the following items to carry out the experiment. A weight of mass equals to 50 grams, right? A meter ruler, knife edge, and a suitable wooden block, right? Pieces of thread, right? Then first one, as the first step of the experiment, you are asked to balance the meter ruler on the knife edge. What is the purpose of the step? Right, balancing this. What is the purpose of the step? Purpose of the step is, right, otherwise the weight of the meter ruler is also come into calculation. Then our purpose is identifying the center of gravity of meter ruler. When center of gravity is identified, right, when the meter ruler is balanced by the center of gravity like this, right, then for our force movement, when it is balanced like this, for our force movement, there's no impact from the weight. There's no impact from the weight of the meter ruler like this. No impact of the weight of the meter ruler. Then purpose is identifying the center of gravity to avoid it from force movements. Identifying center of gravity of meter ruler to omit it what happens to omit it from force movements right. Give me 1 second. Okay. To omit it from force movements, right? B. Draw a diagram of the arranged experimental setup on the table shown below. For the balance situation, just before you take a reading, mark the balance lengths L1, L2 correctly. Take the larger balance length as L1. Right. Then measure from the balance point in the diagram. Okay. Then do we have any idea about the mass of the 60 grams? No, mass of the stone around 60. Mass of the stone is around 60. Right. Mass of the stone is around 60. Then that is a point you need to consider when you draw this. Right. Now knife edge is given. Then knife edge should be placed, and a block of mass was given. A block of suitable wooden block is given. This should be kept on the block, right? This is the block should be kept on the block, right? And pieces of thread are given. Then it should be suspended. Only suspension is acceptable. Should be suspended, right? This is our capital M, and this is the regular mass. This given regular mass, right? That is simple M. And higher the mass, lesser the equilibrium length, no, in a force movement. Higher the mass, lesser the length. Then lesser length is mark. That's important. Then lesser length is, it says, take the larger balance length as L1. Larger balance length should be with the smaller mass, right? Then L1 should be here, right? And L2 should be here. So likewise, it should be marked properly. Otherwise, if you have switched L1, L2, no marks, right? If you have switched L1, L2, right, with a mistake, no marks. Right, part C. Write down an expression for L2 in terms of simple M, capital M, and L1. Write down an expression for L2 in terms of simple M, capital M, and L1. When the system is balanced, right? Then write the force moment about this point. Say G. Add the force moment about point G. Force movement about point G, right? Leftward force movement is due to capital Mg, no? Then Mg L2. Rightwards means clockwise. Clockwise is due to simple Mg L1. G cancels, right? Then capital M L1 equals simple M L2. Write down an expression for L2. Then subject L2. L2 is capital M L1 over simple M. Capital M L1 over simple M, right? For L2, no? Then capital I have switched the terms. Capital M L2, ne? Sorry. Then capital M L2, right? Methane in capital M L2 capital M L2 equals simple M L1, then subject L2, simple M L1 over capital M. Final answer. And even if you write it at once, totally fine, right? I'm writing these equations and the logic, everything, to you to understand. That's what, right? That's what, and that's why, right? Otherwise, when you are writing, no need to mention this much of steps, right? This is an explanation, no? That's why it's a review. D, you are supposed to draw a graph in the experiment. What position of the meter ruler would you place on the knife edge every time when you take the different set of readings for L1 and L2? Always center of gravity, right? Always center of gravity. This position on center of gravity. We are keeping the knife edge on center of gravity. On center of gravity, because otherwise always that force movement comes. Otherwise always that force movement comes from mg. Mg means weight of the meter ruler, right? E. Suppose you have plotted a graph as shown in figure 1 to find the mass capital M, right? Now, in this method, right? In this method, the reason to go for a graphical method, even when we have the opportunity, we have the chance to just do this by a calculation, is to get a more accuracy. Always graphical methods are more accurate, because usually we are taking like 6 readings, right? Then even if you made a small error, these errors are generalized when it comes to graphical methods, right? That's the reason. Otherwise, when capital M is known, simple M is, sorry, when simple M is known and L1 and L2 are known, right? Just by a single calculation, you can find capital M, but we don't do it, right? We don't do it because the error is high, right? Sometimes those things can be questioned, right? Even though L1, L2 and simple M are known, right? Why don't we do a calculation? And why are we going to a complex method like a graph, right? Reason is accuracy, more accuracy. Errors are generalized, right? Suppose you have plotted a graph, right? Okay. Then first one, in the experiment, you have been asked not to take readings for small values of L1 and L2. What is the reason for this? Right? Small values very straightforward, because it has a higher percentage error, or higher fractional error, right? Higher percentage error or higher fractional error. Then the experiment you ask not to take small readings, then because it has higher percentage error or fractional error, right? What is the reason for this? To minimize, right? So rapi lesson liyan reason to minimize to minimize percentage errors or fractional errors in length readings. Right? Oh. Part 2. By selecting the two most suitable points on the graph, calculate the gradient of the graph given in figure 1. The 2 points selected should be clearly marked on the graph using arrows, right? Using arrows. Now they are asked to mark it using arrows. So as I told you before, right? Now you have to select uh, 2 best points, right? You have to select 2 best points, right? Then what about this? See, this one is very clear, no? Right? Mega zoom karat pera. This one is a clear intersection. This one is a clear intersection, right? Then what's the point? This is 10, no? Then 15, 16, 16, and from this side 10, 11, 12, 13. One point is 16, 13, right? Then again, check for another point. Check for another point. What about this? See, this one, it's a clear intersection, no? from x, that is 39. From here 31, 39, 31. Likewise, have two clear points and mark it clearly. Clear points means always, right, it should be an exact intersection like this, an exact intersection like this, exact intersection of the grid. Right, now they are marked and you have to find the gradient. By selecting two suitable points, calculate the gradient, right? Then gradient is delta y over delta x, right? Delta y, my points were right, 39, 31, 13, then 31 minus 13. 31 minus 13, right? Check the units also, right? Now both are in meters, no? Then no need to worry that much about meters and 10 to the minus 2, 10 to the minus 2 meters. Then no need to worry that much about that 10 to the power and the unit, because both are going to cancel 10 to the minus 2 with the unit. Then 31 minus 13 over delta x, 31 minus 13, delta x is 39 minus 16. 39 minus 16, 10 to the powers are cancelled, right? Then no need to worry. This is 13 means 23, 18, right? 39, 16 means 26, 36, 23, right? 23. Then 18 no 23, right? 18 no 23 is 0.78. 0.78, right? So likewise, just find it out, right? Find it out. Then calculate the mass m of the piece of rock in kilograms. Mass in kilograms, right? Then to find the mass, we know, see, graph is plotted between L2 and L1. No, what is our equation? L2 is simple M, L1 no capital M. Our equation is this. See, L2 equals simple M, right? L1 over capital M, simple M L1 over capital M, right? Now gradient is simple M over capital M. Gradient of the graph is simple M over capital M, right? Gradient of the graph L2 over L1, simple M over capital M, right? Then gradient equals gradient, right? Say M dash equals simple M over capital M. Gradient is 0.78. No, gradient is 0.78. Gradient is 0.78, right? Simple M was given 50 grams. Simple M was 50 grams. Then 50 10 to the minus 3 kilograms selling all the capital M, right? Then simplify. Capital M equals 50 times 10 to the minus 3 over 0.78. 50 times 10 to the minus 3 over 0.78. That is 6.41. 6.41 10 to the minus 2 in kilograms. 6.41 10 to the minus 2 in kilograms, right? A small simplification. F. You are also asked to find the mass m naught of the meter ruler using only the other items provided above, except the piece of rock. Only the other items except the piece of rock. Draw a suitable diagram of an experimental setup that could be used for the situation in the space given below. The center of gravity of the meter ruler must be clearly labeled as G. Okay, right. Now only simple M asked to find the mass m naught of meter ruler, right? Only simple M is given, right? No rock. Then we had the previous setup like this, no? Right, then idea again, no, we had the previous setup like this. Now, if meter ruler can be balanced with its weight itself with this, right? It is easily doable, no? Right? Now, say one side was that standard mass. One side was this standard mass simple M, right? Then center of gravity of the meter ruler should be on the other side in order to counterbalance this. Right? Then from here m naught g acts, right? And from here mg acts. These two are balanced about this point of, these two are balanced about this point of, right? So it's how it should be. That's how it should be, right? Should be clearly marked. Center of gravity of the meter ruler should be clearly marked. Yes, it is marked now, right? It cannot be on the same side, right? Otherwise, if that is on the same side, the system is going to collapse, no? Right? So obviously, we know that cannot be on the same side, right? Otherwise, the system collapse, right? Should be on the two different sides, right? If you switch the sides, that's fine. If you switch the sides, it will be fine. It will be fine, right? Okay, that's it about question 3 also. Right? Any questions? Any questions? Any clarifications needed? Or just tell me if it's clear enough. Say it's clear if clear. Any questions? Right? Practice all the questions, practice questions, practice questions, and get used to all question types. Right? Get used to question types and practice all types of questions. Otherwise, right, don't just see a new type of a question at the exam for the first time, right? It cannot be like that, right? Always you have to go to the exam, sit for the exam with all the experience we have gained along this journey, right? With all the experience we have gained along the journey, right? With all the experience we have gained along the journey, right? Otherwise, right? Otherwise, if you saw something for the first time, right? If you saw a new type of a question for the first time, right? Sometimes you might not be comfortable as much as a familiar question. That's how it is. Sometimes, therefore, practicing all the possible types of questions is the thing here, right? Practicing all the possible types, right? So always we have to practice, right? Have to practice. Can you explain the last part again? I mean, F part of part F. Part F. In part F, now if you are balancing the meter ruler, right? If you are balancing the meter ruler, then its weight should be somewhere around the middle of the meter ruler, no? Right? Its weight should be somewhere around the middle of the meter ruler, say somewhere here, right? Then to counterbalance this, to balance this, then that MB should be put to one side, right? Like this. Then it is going to go down. Then to counterbalance, the weight should be suspended from the other side like this, right? Weight should be suspended from the other side, right? Otherwise, how to counterbalance this force movement created by weight of the meter ruler, right? Methaning enovane ekak like this. To counterbalance it, this should be suspended from the other side. Then weight act somewhere here, right? And the other mass is here, right? Weight is here, other mass is here. Then it can be counterbalanced. Otherwise, if both are at the same side, the system is going to collapse, right? Got the idea? Is it clear enough? Right? Because that is all about balancing this. Only two forces, mg of meter ruler and that m naught g of meter ruler and mg of that additional mass. That additional mass means given mass, right? Clear enough? Right, clear. All right, then if no questions, we can wind up. Right, 1 second. Right, if no questions, we can wind up. Right, if no questions, we can wind up. Right, then work hard. Right, work hard, study hard without wasting the time. Right, we are now in the last month. Right, just last month. Right, and lots of question discussions and seminars. Those things are also coming from my side. Stay connected. Then get the advantage. Right. Right. Okay then. The support seminar question papers are also out. Right. Probably I'll be taking another allocated day, another different day allocated for the discussion of the support seminar questions also, right? So likewise, I'll be discussing the other important papers also in the during the month, right? In the month coming up, right? So stay connected and work hard, put your maximum effort. That's the thing, right? Put your fullest, right? So as you have no regrets after the exam, right? Put your best. That's it. Otherwise, if you feel like you didn't put your best to the exam, right? That's a regret, right? If you feel like you didn't put your best to the exam, right? That's what we call a regret, right? So don't let regrets, right? Don't let regrets happen after the exam, right? After the exam, don't let regrets happen after the exam, right? Put your best, right? Give your best shot. That's the thing, right? When you have given your best, then you have your satisfaction. You have the self satisfaction, right? Self satisfaction about you that you have done enough, right? Otherwise, if you also feel like you haven't done enough, right? Then that is not a good feeling to have. Can you send in groups to write? Yeah, I'll send the support seminar papers in the group, right? Don't worry, I'll send. We'll send in the groups. Right, okay. Then if no questions, we'll wind up. Right? Work hard. Work hard. See you in the next class. Right? All right. Then good night and goodbye. Stay safe and most importantly, work hard. Right? See you in the next class.